Hi folks, it's Bruce again and welcome to my Rocky Mountain Labs. And today we're taking a look at a vintage B&K electronic multimeter. This is the model 277, has an FET front end. It measures voltage, both plus and minus DC, AC voltage, high and low ohms, and DC amps. And we're going to take a look and see how this thing performs. It's in a nice condition. As you can see, the case has few if any scratches. Faceplate looks nice. Same thing for the sides. The handle's in good shape. Where the battery compartment and you take that whole back assembly off, and that's where you calibrate. So let's see how we do with it, huh? Okay, well this B&K 277, one negative lead that's common to two sets. We have a red current and ohm meter lead, and then we have a DC probe. And the difference is the DC probe has 100 kiloohms of resistance in the tip, and that helps further isolate the unit and reduce the amount of hum and noise and so on. So we have the 100K DC probe plugged in, so we're obviously going to try and measure some DC voltages. And let's first of all start with a battery check. Okay, the battery says we are okay, which is good because I just changed the batteries the day before yesterday. We've got a nice C-cell, I think it's the copper top battery, and then we have a 9-volt, again copper top. And then we're going to go past the DC negative, going to DC positive. Then we're going to take a moment, we're going to connect up this lead and turn on our DC calibrator up there, and we'll give her a go. Hang on. Okay, well we've applied 1 volt, which I'm verifying with my HP 34401A. And that's coming from our DC calibrator up here, which is set to 1 volt. And we can see on the meter that the needle is all the way right over the 1 volt scale. We are on the 1 volt scale right now, obviously. Let's go ahead and we're going to turn this thing up. I'm going to set you up on a tripod so I can do some other manipulation without losing this picture, so hang on. Alright, we're on the 1 volt, and we're going to go to 0.9. That would be 0.9. 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's change our scale. We are on the 0.3 volt scale. Let's go ahead and check 1, 2, 3. There we go. And then let's back down again, and we will go to the 0.1 volt scale, and we're going to go 0.01, 2, 3, 4, 5, 6, 7, 8, 9, 0.1. Let's now get ourselves off of the 0.1 scale. It's 0.3, there's 1 again. And we'll go to the 3-volt scale. Okay, we're on the 3-volt scale, and we're going to go one volt, 2 volts, 3 volts. Looks good. We're going to go to the 10-volt scale. We are on 3 volts where we left off. That looks good. 4, 5, 6, 7, 8, 9, and 10. Okay, looks good. Going to the 30-volt scale. This will be 10 volts, 20 volts, 30 volts. Okay, going to the 100-volt scale. And we're on 30 volts, going to 40, 50, 60, 70, 80, 90, and 100. Okay. 300-volt scale. This would be 100, 200, 300 volts. Going to the 1000-volt scale. We are reading at the moment 300. There's 400, 500, 600, 700, 800, 900, 1000. Okay. We're done with the DC scales. Everything looked pretty good. Let's go to the AC and we'll check it out. Give me a moment. Alright, we've now put ourselves in the AC voltage position. We're on the 0.1 volt scale, and you observe the needle. I'm going to go ahead and call out the voltages. Right at the moment, that would be 0.1 volt full scale. Two, 3, 4, 5, 6, 7, 8, 9, and 10. That'd be 0.1 volts full scale. I did notice there was some nonlinearity towards the low end there, so we were low till we hit full scale. Full scale looks pretty good. Let's take her back down. 9, 8, 7, 6, 5, 4, 3, 3, 2, 1. That would be 0.01. And essentially 0. I'm going to recheck 0 just to see what we've got. Looked pretty good. Okay. That us try 0.3 volt scale, and we're going to be 0.1 on a 3 volt scale. That's the bottom scale. 0.2, 0.3. Right on the nose on 3. A little low on 1 and 2. And then we're going to go to the 1 volt scale. We're reading 0.3 right now. We're on the top red scale. 4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1 volt. Let's go to the 3 volt scale, and this would be 1 volt, 2 volts, 3 volts. And we're going to go to the 10 volt scale. We're reading the top. We're at 3 volts right now. 4 volts, 5, 6, 7, 8, 9, 10. Alright, we go to the 30 volt scale. Right at the moment we're on 10 volts. We'll change our range. Alright, this will be 10 volts. 20, 30. And going to the 100 volt scale. Should be on 30, 40, 50, 60, 70, 80, 90, 100. Okay, we're going to go to the 300 volt scale, and we are right now the best I'm going to be able to do here is 100, so we'll put her up to 100 volts. That would be 100 right there. And it actually looks pretty good on the scale right now. And that's the best we can do with our AC calc, because we don't have AC generation higher than 100. So we're going to move to the next step. Let's take a look at the ohms. Alright, well, we're going to check the resistance, in this case the low ohm scale. We are using a resistor stat 2 with resistance in decade steps from 1 ohm to 100,000 ohm per step. And first thing we have to do is, everything is set to 0 on the resistor stat, so we're shorted. I'm going to plug in, I'm going to set my 0. And I'm going to disconnect, and I'm going to check my span, and I'm on infinity on the span, so that's good. Go ahead and plug back in, and let's go to the first step, which is 1 ohm. 2 ohms, 3 ohms, 4 ohms, 5, 6, 7, 8, 9, 10. Here's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There's 100 ohms, and that's on the R times 1 range. Let's go ahead and check to the R times 10 range, and we'll get ourselves back to 0 here. 0 looks pretty good. Span. Infinity, that's good. Okay, let's go ahead and do this would be 10 ohms, 20, 30, 40, 50, 60, 70, 80, 90, 100. Here's 100 again. 200, 300, 4, 500, 6, 7, 8, 9, 1,000. Alright, we've reached 1,000. Let's go to the R times 100, get ourselves back to 0, check our 0. 0 looks pretty good. And then we're going to go, yeah, let's go hundreds. There would be 100, 200 ohms, 3, 4, 5, 6, 7, 8, 9, 1,000 ohms. Okay. Here's 1,000, 2,000, 3, 4, 5, 6, 7, 8, 9, 100,000. All right. Next step, R times 1,000. Going 1,000 this time, okay. 1,000, 2,000, 3,000, 4,000, 5,000, 6, 7, 8, 9. There's 10,000. Back to 10,000. 20, 30, 40, 50, 60, 70, 80, 90, 100,000 ohms. Let's check that span. Looks like we're off a little. We are. Yeah, right on the money now. Alright, and we go to the 10,000 step. 0 looks good. Let's check the span. Span looks good. Let's go 10, 20, 30, 40,000, 50, 60,000, 70, 80,000, 90, 100,000. There's 100,000 again. 200, 300, 400, 500, 6, 7, 8, 9, and that would be 1,000,000. Okay, at this point we're going to switch boxes because I've got another decade of range on the other box. So let's try that. All right, we're reading the R times 100,000 range. We're trying to check the zero right now. We've switched to the high ohms, because for sure we should have switched by this point. And zero looks good. Let's check the span. Span is just a hair. There we go. Check the zero once more. Looks good. All right, let's go 100,000, 200,000, 300,000, 400,000, 500,000, 600,000, 700,000, 800,000, 900. There's 1,000,000 right in the middle. Okay, if I go back to 1,000,000 here, I'm using the highest decade on the unit now. 1,000,000, 2,000,000, 3,000,000, 4,000,000, 5,000,000, 6, 7, 8, 9. There's 10,000,000. Okay. And we go to the next range. Okay, we are on the R times 1,000,000, the highest ohm scale. We are reading zero right now. We're going to check our span. This would be 10 megohms, which would be middle of the meter. Okay, so let's go ahead and run the test. Here would be 1, 2 megohms, 3 megohms, 4 megohms, 5 megohms, 6, 7, 8, 9, 10 megohms. And I am showing just a hair low for some reason. But it's 10 megohms. It's about a needle width off of it. And that's as high as my standard goes. So let me see what I've got on the shelf. Alright, I pulled a 100 megohm resistor off of my shelf. I've zeroed the meter. You can see it in the background. And I'm going to go ahead and clip in the resistor. And the meter is reading 100 on the dial. That'd be 100 megohms within 1%. And it's right. So we're good. Okay, we're on the 1 microamp scale. That's the most sensitive amperage scale. We're at 0, and we're going to start dialing in. Let's try 0.1 microamps, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Go all the way back and go to the next decade, and there's 1. That'd be full scale. Okay. Let's go to the 10 microamp scale. And let's see, we need full scale to check here. Here is 1 microamp, 2, 3, 4, 5, 6, 7, 8, 9. Next decade, and we get full scale. Okay, we are on the 100 microamp scale, which would be 0.1 milliamps. And I'm going to dial in, this would be 0.01, 0.02, 0.03, 4, 5, 6, 7, 8, 9, and this would be 0.1 milliamps full scale. Okay, we're on the 1 milliamp scale, but it reads on the dial 0.1 milliamps. However, we just did 100 microamps, which is 0.1 milliamps, and the next step is 10 milliamps. So for some reason, this range switch is designated wrong at this step for the current. It's 1 milliamp full scale. Right now we're at 0. Let's check full scale. There's 1 milliamp full scale. We go back down to 0. Let's check. This would be 0.1 milliamps, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Go all the way back down to 0. We'll go to the next decade over here and go up. And we've got 1 milliamp full scale. Okay, let's check the 10 milliamp full scale. Okay, and we're going to dial our machine here. All right, and 10 milliamp full scale, that would be full scale here. Here's 0.1, 0.2, 0.3, I'm sorry, this is 3, 4 milliamps, 5 milliamps, 6, 7, 8, 9, and 10. Okay, we go to the next. Go to the 30 milliamp scale. And we're reading the black line for volts, DC volts and milliamps. And this would be 10, 20, and then full scale, 30. Okay, and all right, we are on the 100 milliamp scale, and we are in the 0 to 100 milliamp range. This is our highest range on this unit. And we're going to go with 10 milliamps at a step. So here's 10, 20, 30, 40, 50, 60, 70, 80, 90. Then I bring up 91, 92, 93, 94, 95, 96, 97, 98, 99.9, and we are full scale. So 999, we're reading 100 milliamps full scale. Now, if I dial to the next step, which is 300 milliamps, this 100 should be 1/3 of the scale. And there she is. And if I go to the last step, which is 1 amp, then we should be reading 0.1 amp, and we are. Okay, that concludes the amperage scales. Okay, so we've given you a tour of this unit, and we've tested every function and range on it, and it looks good. It's a nice meter. Well, we're talking something that has got to be, oh, I don't know, 45, 50 years old. I mean, it's not a new meter, but they're fun to work with. Analog meters, it's just fun to see the needle move, the electromotive force that's going in there, turned into magnetic force and moving that needle. And it's actually a very useful unit when you're trying to observe something that's fluctuating, maybe bouncing between a couple of values. It'll mechanically dampen out those bounces, and you'll wind up getting an average that's a readable average. And you can adjust a unit, say peaking a short wave or something like that, and it'll automatically cancel out those the jitteriness that would otherwise be there on a. It'd be almost impossible to do on some digital meters where you're jumping between a couple of values. All you're going to get is gibberish. Not so here. So it's got a function, and I always wanted this particular unit when I was a younger guy. I wasn't able to afford it back then, but it's fun to have had it now. Along with it, we're going to provide the manual. I'm going to go ahead and give you the printed copy of this. It was a colored copy, and I also was able to print out it's got the calibration procedures and all that, but I was able to print out the schematic diagram. It's always useful to have. So here we have the schematic. Very hard to get unless you're willing to pop some bucks for. And we'll provide that along with the unit. So thank you for listening and bearing with this otherwise kind of tedious video. That's the way these meters are. There's so many functions and so many ranges that it can be very tedious to actually test. But thanks for listening, and good bidding, and we'll see you again.